All right, let's dive in. We're looking at two really incredible ocean creatures today, the mantis shrimp and the pistol shrimp. I got to say, even just glancing at the research you sent over, uh, I'm already blown away.
Yeah, it's amazing how such small creatures develop these remarkable adaptations. I mean, they don't just survive, they really thrive.
Exactly. So first up, the mantis shrimp. Gotta admit, I'm kind of partial to them. I mean, just look at them. The colors are incredible. But I'm guessing there's a lot more to them than meets the eye,
Oh,
right?
absolutely. You know, the peacock mantis shrimp, well, all those vibrant colors, the reds and greens, they're actually directly linked to their vision, and their vision is really complex.
Okay, so walk me through this. What makes their vision so special?
Well, think about human eyes. We've got three types of color receptors, right? Mantis shrimp, they have somewhere between 12 and 16.
Wow. 12 to 16. So they're seeing like a whole spectrum of colors that we can't even imagine.
Exactly.
Okay, so what does that mean for them, like practically in their day-to-day life on the reef?
It gives them a massive advantage when it comes to hunting. You know, they can see tiny color changes in camouflaged prey, like an octopus hiding in the coral. It's also vital for communication. They use these subtle color shifts to signal to each other.
So it's like their own secret language invisible to, potential predators.
Yeah, precisely. But the mantis shrimp isn't just about good looks and great vision. They're also incredibly strong, especially well, there's a type called smashers. They have these incredibly powerful claws, hammer-like claws.
Yeah, those claws are unbelievable. I've seen videos of them smashing through like aquarium glass. I
Yeah.
mean, how on earth do they generate that much force?
Well, their punch is one of the fastest and most powerful movements in the entire animal kingdom. They can accelerate those claws to 100 kilometers an hour in, get this, less than zero point 0.3 milliseconds. That's 10,000 times the force of gravity.
10,000 times.
Yeah.
Okay, that's just mind-blowing.
Yeah.
So what's the science behind this superpowered punch?
Well, it's not just the speed, it's also this fascinating phenomenon called cavitation.
Cavity.
Yeah. So when the mantis shrimp strikes, the rapid acceleration of its claw creates a low pressure area in the water. And this causes the water to basically vaporize, turns into tiny bubbles. And these bubbles collapse almost instantly.
Hold on. So these bubbles, they're not just air, right?
Yeah,
What happens when they collapse?
you're right. They're not air. They're almost like empty space formed by that rapid change in pressure. And when they collapse, they generate intense shock waves and heat. And those shock waves combined with the impact of the claw, well, that's what allows the mantis shrimp to, shatter shells, stun prey.
Like a double whammy, the punch, and then these mini explosions from the collapsing bubbles.
Yeah.
That's incredible.
And what's really fascinating is the same principle, this cavitation. It's also used by our next shrimp superstar, the pistol shrimp.
Okay, let's talk pistol shrimp. They might not have the same flashy colors as the mantis shrimp, but I've heard their sound is something else.
They're much smaller, for sure, usually only about 3 to 5 centimeters long. But the pistol shrimp has developed its own pretty unique way of using cavitation.
Cool.
It's got a special claw, and when it snaps shut, it shoots out a jet of water at, well, unbelievable speed.
So it's like a water gun, but way more powerful, I guess. How fast are we talking here?
Well, believe it or not, the water jet from the pistol shrimp's claw can reach speeds of, you guessed it, 100 kilometers per hour. And just like with the mantis shrimp, that rapid movement creates cavitation bubbles, and they collapse with incredible force.
Wow, so they're both reaching these like super fast speeds, but through completely different mechanisms. That's incredible. And you said this snapping creates a really loud sound. How does that work?
Well, those collapsing bubbles, they generate an incredibly loud popping sound, over 200 decibels. That's comparable to the sound of, like, a jet engine taking off.
200 decibels. Whoa, that's got to be like really disorienting, even painful, right? For other creatures nearby.
It's powerful for sure, but it's also incredibly short. It only lasts a few thousandths of a second. Divers often describe it as kind of a clicking or snapping sound on the reef.
So they're not just snapping their claws, I don't know, for fun, right?
Right.
What's the purpose of this intense sound?
The pistol shrimp uses this sound for, well, a lot of things.
Yeah.
Stunning prey, defending their territory, and even communicating with other pistol shrimp. It's really a fascinating example of how one physical adaptation can be used for so many different purposes.
So we've got these two shrimp, both with incredible power, both using this mind-blowing physics phenomenon of cavitation, but they go about it in such different ways.
Exactly. The mantis shrimp, it's all about brute force, that lightning fast punch creating those cavitation bubbles on impact. The pistol shrimp, on the other hand, it's more about control, generating cavitation bubbles with a precisely controlled jet of water from that snapping claw.
It's like evolution decided to, experiment with two completely different approaches to the same problem, how to pack a punch underwater. And speaking of adaptations, the pistol shrimp has another trick up its sleeve, right? Something about a partnership with a fish.
You're thinking of the goby fish. Yeah, the relationship is, it's a classic example of symbiosis.
Okay, I'm intrigued. Tell me more about this unlikely duo. Like, how does it work?
Well, the pistol shrimp digs and maintains a burrow in the seafloor, and it shares that burrow with the goby fish. The goby, with its excellent vision, acts as a lookout, watches for predators while the pistol shrimp focuses on keeping the burrow clean and safe.
So the shrimp is the landlord and the fish is the security system. That's pretty clever. But how do they even communicate? I mean, they're completely different species.
It's amazing. They've developed this intricate communication system using touch and visual cues. The shrimp will often stay in contact with the goby using its antenna, and the goby will signal danger with specific movements. It's a remarkable example of interspecies cooperation.
That's incredible. Really highlights how interconnected everything is in the ocean. This deep dive is already one of my favorites. We've got stunning colors, underwater explosions, amazing physics, and interspecies friendships.
And we're just getting started. There's so much more to discover about these fascinating creatures.
Well, then let's keep diving deeper.
It's just amazing how these shrimp use cavitation, isn't it?
It's incredible. They're like tiny underwater superheroes with these superpower punches.
Exactly. And it's not just about, brute strength. It's about precision and timing and, well, a deep understanding of physics, it seems.
Before the break, we were talking about that partnership between the pistol shrimps and the goby fish. Such a cool example of like teamwork in nature.
It really is. And that partnership goes even deeper than we've talked about so far. The pistol shrimp's burrow, it's not just a shared home, it's also a carefully constructed sensory environment.
A sensory environment. Okay, now I'm really intrigued. What do you mean by that?
Well, the pistol shrimp, it uses its snapping claw not just for, hunting or defense. It also uses it to constantly assess its surroundings.
So it's like echolocation, like bats use.
It's similar, yeah. The sound waves from the snap, they bounce off objects in the environment, and the shrimp uses those echoes to create like an acoustic map of its surroundings.
It's like a built-in sonar system.
Mm-hmm.
Wow, that's amazing. But wouldn't all that snapping also attract predators? Seems like it would make them an easy target.
That's where the goby fish comes in. Remember, it's constantly on the lookout for danger. If it senses a threat, it signals to the pistol shrimp, and they both retreat into the safety of the burrow.
So it's like a two-way street. The shrimp provides the home and the sonar, and the fish is like the eyes and ears of the operation. I'm curious, how did scientists even figure out this whole communication system? I mean, it seems like it would be pretty hard to observe in the wild.
It took a lot of clever observation and some really creative experimentation. Scientists used underwater cameras and special microphones called hydrophones to record the sounds and behavior of the shrimp and the goby in their natural habitat.
Wow, that's some serious scientific detective work. It really shows how dedicated these researchers are to, understanding these amazing creatures. Okay, let's switch gears for a second. Back to the mantis shrimp. We talked about their incredible punch, but what about their vision? With all those extra color receptors, do we know how they actually perceive the world?
It's a question that's fascinated scientists for a long time. I mean, try to imagine a world where colors are not just, brighter and more diverse, but also arranged in patterns and combinations that we can't even comprehend.
It's like trying to imagine a new dimension or something. It blows my mind. What are some of the theories about how they use this enhanced vision?
Well, one theory is that mantis shrimp use their vision to detect polarized light. Polarized light waves, they vibrate in a single plane, unlike the more random vibrations of unpolarized light. Many animals, like some insects and birds, can see polarized light, and it's thought to help them with navigation and orientation.
So for the mantis shrimp, this polarized light sensitivity could be like having an internal compass.
Exactly. It could help them navigate the reef, find their way back to their burrows. Another theory is that their vision helps them detect fluorescence. Some marine organisms, like corals and certain types of algae, they emit light when exposed to ultraviolet radiation.
So they're basically like glowing underwater.
Yeah, it's a pretty spectacular sight, and it's thought to play a role in communication and camouflage. Mantis shrimp might be able to see those fluorescent patterns, which would give them a big advantage in, finding prey or potential mates.
Wow, it's like they have this secret decoder ring for the reef's hidden light show. It's incredible.
Yeah.
But I have to ask, what are the practical implications of all this research? I mean, besides just being, super cool, does understanding these shrimp actually benefit us in any way?
Absolutely. Studying these creatures isn't just about, expanding our knowledge of the natural world. It's also inspiring innovation in all sorts of fields. For example, the mantis shrimp's punch, it's inspired engineers to develop new materials and designs for things like impact-resistant armor and helmets.
So we could be seeing like mantis shrimp-inspired body armor for soldiers or helmets for athletes?
It's definitely a possibility, and it's not just about protection. Researchers are also looking at cavitation as a potential non-invasive surgical tool. The precision and power of cavitation could be used to break up kidney stones or even target cancerous tumors without harming the surrounding tissue.
Wow, that's incredible. It's like science fiction becoming reality. And what about the pistol shrimp sonar? Any practical applications there?
Oh, definitely. The pistol shrimp's ability to map its surroundings using sound waves. It's inspired the development of new sonar technologies for underwater exploration and navigation. These bio-inspired sonar systems, they're turning out to be much more efficient and sensitive than traditional sonar, which allows us to explore the ocean depths with, greater clarity.
It's amazing to think that these tiny creatures are leading to such big advances in technology. It just shows how important scientific research is and how important it is to protect these creatures and their habitats.
I couldn't agree more. These shrimp aren't just, fascinating subjects of study. They're also vital members of their ecosystems, and they hold the potential for groundbreaking technologies. Protecting them is essential, not just for their own sake, but also for the future of, scientific discovery and human innovation.
It's amazing to think about all the things we've learned, just from these two little shrimps.
It really makes you realize how much we still have to discover about the ocean and how much potential there is for, learning from nature and applying those lessons to our own lives.
I mean, we've talked about the mantis shrimp's punch, the pistol shrimp sonar, but what about other areas of research? What are scientists most excited about when it comes to these shrimps?
Well, one area that has a lot of potential is optics. The mantis shrimp's vision, especially their ability to see polarized light, could lead to incredible new imaging technologies.
So are we talking like cameras that can see through fog or smoke?
Exactly. Or medical imaging devices that can, detect diseases at much earlier stages.
Wow, that would be revolutionary. And what about the pistol shrimp's snapping claw? Are there any other potential applications besides sonar?
Researchers are looking at using it as a model for microfluidic devices. These are like tiny devices that can manipulate fluids at a microscopic level.
I'm not sure I follow. What would those be used for?
Oh, all sorts of things. Medicine, chemistry, biotechnology. We could see pistol shrimp-inspired lab-on-a-chip devices or even new drug delivery systems. The possibilities are pretty vast.
It seems like every time we learn something new about these shrimp, it opens up a whole new world of possibilities. It really underscores the importance of, supporting scientific research and protecting these amazing creatures and their habitats.
I completely agree. These shrimp are, they're not just fascinating research subjects, they're also, vital parts of their ecosystems. And they hold the key to, well, potentially groundbreaking technologies. Protecting them is, it's crucial, not just for their sake, but for the future of, scientific discovery and human innovation.
Well, this has been an incredible deep dive into the world of the mantis shrimp and the pistol shrimps. We've learned about their amazing adaptations, the mind-blowing physics they use, and their potential to inspire some truly revolutionary technologies.
It's been a pleasure sharing these insights with you. Hopefully, it sparked a little curiosity and wonder about the natural world.
And to our listeners, we encourage you to keep exploring, keep asking questions. The ocean is full of mysteries waiting to be uncovered. Who knows? Maybe you'll be the one to make the next big discovery.
Thanks for joining us on the deep dive.
Until next time, keep diving deep.